Here is the lesson on figuring out why do we have to apply, what is the application of vectors in modeling. So this is the parsing, model, velocity and force. So in this case you can see at one point, Valerie, can you read this quickly?
Says two forces F1 and F2 with magnitude 10 and 20 pounds, respectively, act on an object at point P. Find the resultant force acting at P.
Okay, so the point is this P, agree? Okay, so at this point, there are two students are pulling the object maybe. One with the magnitude how much? Can you underline this? So that's the magnitude of the force. So I can call, let's call F1. So this F1 basically represents the force in that direction. They gave you also at what angle is he pulling, got it? That is given. Now your question will be, oh my God, we never learned at that point, angle at that point, right? So what we do is we shift it, got it? The whole thing, instead of wherever that place is, all you do is push this over here. Make sense? So what I'm doing, I'm trying to translate this point P over here, P prime. So this will be here, correct? So then the blue color one, so the blue, this will be is something, because we want to know, our goal is to figure out the horizontal and vertical component, got it? So this part I'm making like this, exactly 45, I think. So the blue one. So this is that same thing, okay? Doesn't look like. I think this is better. This is better? So that F1 is the same one, correct? So the moment you have this, let's draw this and I'll wipe off the other one. And this will be like this. So the reason to make this something like this, 150 is like this. Okay, so that is F2. So my question to you is right now we already have this as 45, agree? 45, agree? And the other one is how much? 100. Is that okay? Now we can write the coordinates and what is the position? They are also called position vector. What does position vector mean? Can I write this now? So all I need is I place this point right here, okay? So this takes off. No more this, got it? Make sense? And now you know the answer. So let's write down the force. So the formula that we are going to use is the resultant vector, or we are going to use any vector is always written as the magnitude of the vector and cosine of the angle where theta. This is the angle actually. This is the angle formed by. So I'll just write down this angle formed by vector in the with the positive did I write? I don't know whether I wrote it somewhere. With the positive direction of x-axis or positive x-axis. Make sense? So it always starts with that dot. Okay. Now let's write down. So can you tell me what will be the vector F1? And remember, you can write two ways with the help of I and J form. I will use directly component form because that is more important. So what is how do we write this first one?
150.
Say it again?
150. Oh no, wait, 45.
How much was this pound? How many pounds was this? The first student is doing what? 10. So this distance is like a 10 here. 10 pounds. It's like that much of force, magnitude force.
Oh, yeah.
45 is the direction, right? So that's 10. And how much is this side? 20 pounds, got it? It's like how much magnitude. So when I write this, what is that for the first one, for the first student? What is this part? 10 cosine. What's the angle made? How much is this angle? 45? No, nobody there. Nathalie agree? I'm thinking of this is let's just think that this is first student, okay? This is like a first student. He's pulling this side, right? Now he has some at what angle is this pulling something like this? So if I'm a student, I'm pulling something like, so at what angle is it's given to you? They gave you 45 degrees. You cannot question why. It could be they could have given this as 32, whatever that, or maybe up like this, pushing like this up, like 70, 80 degrees. So my thing is, did you understand it? Why it is 10 cosine of 45? Yes or no? Did you get this? And the second one is what? Basically it's the same thing what I showed right there. Okay. So the second one again you write is 10. Remember yesterday's problem? The jet was flying on the north. Do you remember that part? The jet was flying which side? In the north. If you remember this north east side, and so going with 765, and we found this part. Remember that big problem with it, and you saw that it was bearing some 32 degrees. I think I took, but then you have to take not 32. It is 90 plus 32. I think 132, 90 plus 122. Yeah, 122 because 90 plus 32. Remember yesterday's problem, and then we say okay, this was 765 cosine of 122 and 765 sine of 1. Do you remember that part? Yesterday the jet is flying in the northwest side, and there was a wind blowing like this in the northeast side, correct? So that kind of thing is just another application here with the forces. So we want to know about the force. So this time it will be 10 of sine of 45. Agree? Yes or no? Got it? Once you know, then let's write the second force. And the second force is, Misael, would you like to share quickly? The other student, this is the second student. What does this second student does is, he's pulling from another angle, 120. Can you see the 120? I mean, they could give anything else there. So, but my question is, can you write this?
Would it be 20 cosine 150?
Correct?
And then 20 sine 150.
Very good. So now you have like, so the resultant vector is, what I'll do is, I'll try to make a nice thing. I don't want this now. I want to see what is the resultant, where is the object going? So the object is right here now. This is the object. Where does it go? So the question is asked, find the resultant force acting at P. So all you do is F1 plus F2. And yesterday, you know, this means it's always the diagonal of the parallelogram formed by those two vectors. So if you see this is, I don't want this now. Let me think of only those two vectors. I can draw another vector. We can complete a parallelogram based on. See, I can draw something like this. Watch this. So I'm going to do exactly this orange color vector like this, and then the dotted one. Do you see this? So you create a parallelogram. The definition of resultant force, that is that when you add two vectors, it's always the diagonal formed by, I'll use this one. See this part? So this one. Can you see this part? So this was F vector, F1, and this was F2, and then this is what? F1 plus F2. Got it? Are you getting something at least? So now the question they're asking us, hey, what is this resultant? Let's do that. Now remember, this 45 and 150 are, there are two ways you can do without calculator, but you saw yesterday's, there was so much confusing numbers. They don't have to be nice numbers. These are nice numbers. We know what is cosine 40 by root 2 to all that, right? We know this 150 also will be like, remember, 150 is 30 degrees from 180, like, so that's minus cosine 30 and like that. But I want you to just focus like this, F1 plus F2. What do I add now? The new vector will be, you add remember the formula? If there are so if you have two vectors, U, and do you remember A1, A2, and the other one is what? B1, B2. All you do is what is U bar plus B bar. So it is, you add the, remember this? So you adding A1 plus B1, and then you're adding A2 plus B2. Nobody's saying yes. Got it so far? And then I'm just doing this tan of cosine 45 plus 20 of cosine 150, and the other one is, what is the other one? So you combine this two, and you combine this two. Agree? So it is 10 sine of 45 and 20 sine of, nobody's saying yes. Got it, right? And the rest is what you use your calculator. Now this answer is, because of the time, I want you to figure out yourself, whatever that, you'll get something, okay? So, and then you use the calculator. You could do this without calculator. Actually, if I wanted to show you quickly, you know cosine 45 is what? Anybody remembers root 2? Do you remember cosine 45? And that 2 crosses out with 10, become 5 root 2 times. I'll just try to make it kind of easy, just in case. I'm doing mental maths here, okay? Because of the time. So you can use calculator directly, straight away. I'm just saying, this was 2 and 2, this goes 5. This would be 5. This will be 5 root 2 plus, and this will be minus, because that's like, you know what, this is 180. If you do 180 minus 30 is 150. That's in the second quadrant. Cosine is negative, so you get like a minus, and 2 divides 10, it becomes 10 root 2 again. Do you see? In kind of a thing. And the same thing the other side, it will be 5 root 2, but this will be positive there. You can always check. I messed up here. It's plus and 10 root 2. Basically what you get is minus 5 root 2, minus 5 root 2, and this is 15 root 2. Is that okay? Again, I repeat, these angles could have been some stupid numbers, so not always you can do like that. You can just use a calculator. But I would just forget right now and just say, just remember this. That's the new. This is the result. Done. You're done. But if they had to ask in what direction, suppose the question was asked in what direction, then what is the formula? Do you remember the formula for direction? What's the formula? You want to know how much is this angle? So this part is like your x and this is like your y, agree? So the formula is theta is, yesterday we deal with the, in what direction does the jet goes? What is the actual from true direction? Even the plane was going in one direction, and you see, this student is putting too much of force here. So naturally it goes towards his side, do you see? So it goes somewhere here. So it's tan inverse of y over x. So all you do is you put this on the calculator, on the black calculator, up tan inverse, this is up and that is down, that's it. And you may get a negative angle here. So because on the calculator it will give you kind of this angle like this. This is the angle which will be given to you. Then this is same as that angle, and then you have to always subtract and you get the answer. Make sense? And I'm going to do this quickly. You don't copy. You can always you have this. Now in physics they have, if I pull this with some like 3 pounds or 5 pounds, and I move this from that 3 feet. Let's say 3 feet. The definition says how much work done is always force. How much force I am putting, multiply by what? Distance. So let's see, now in this example, such simple example, watch this. How much work is done in lifting a 20-pound weight 6 foot off the ground? So the force applied in the okay, so what I'm going to do is, I will make this video separately on this, okay? So what I want you to do is, because everything cannot be completed, this problem, and there is another problem on motion where work is done with the vector form, we'll see that. I'll make a video in the evening and hope that helps. But my question is, did you get this? 100%? So resultant force is that. That's all I wanted to show you. Okay? Okay, we'll continue this tomorrow more on this, but I want to make a video so that it can help you. Have a good one. And do not forget to complete 7.5.